Okay, 4.2 recap. It's going to be pretty short. Basically, what we dealt with is the idea of implicit functions and implicit differentiation. The idea being here that y is implied to be a function of x. And usually that means that we can't just write y equals f of x because we have something that's too complicated to do that. So for example, y squared equals x. We can't actually write this as y equals a function of x. We have to write it as y equals two different functions of x. So it's actually easier in this case to take the derivative implicitly. The derivative of something squared is 2 times the something to the power of 1 times, chain rule, the derivative of the something equals the derivative of x. So then we can just solve for the derivative, and we get that it's 1 over 2y, and we're just going to stop there because the derivative is in fact a function of y, not a function of x. And we talked in the original video about why that is true. Steps for doing implicit differentiation. Step one, we're going to, give me just a second. I'm going to jump back into the book and make sure that I give you the language to be as clear as possible. Step one, we differentiate both sides with respect to x. Step two, we collect the dy dx terms on one side. Step three, we factor out the dy dx. And step four, we solve for dy dx, which of course would just involve dividing both sides by whatever was left after we factored. Quick example, x squared plus y squared equals 2x. Let's say plus y. 2x plus 2y, y prime equals 2 plus y prime. We're going to collect these terms on one side and put everything else on the other. So we've got 2y, y prime minus y prime equals 2 minus 2x. Factoring out the y primes, we get that y prime times 2y minus 1 equals 2 minus 2x. And I've run out of room here, but clearly, hopefully, you can see that I would divide both sides by 2 minus 1, and the derivative of y with respect to x is 2 minus 2x over 2y minus 1. Guys, that was the whole section, because everything else we talked about tangents and normal lines using the equations of ellipses, which aren't always easy to, again, just not always easy to write as a function of x. We talked about derivatives of higher order. We talked about rational powers of functions, which basically told us that we can just continue to use the derivative of x to the n is equal to nx to the n minus 1, even for rational powers. The only thing we have left is irrational powers, and we'll get there. Be patient. All right. Thanks for watching. Hope you learned something.